Hello students, in class 12th I have told you about the nuclear fission. Now I am taking the nuclear fusion or the thermonuclear reactions. Nuclear fusion or thermonuclear reaction. In nuclear fission, you have seen that a big nucleus is broken into two fragments of approximately equal size, and the products so found have more binding energy per nucleon than the parent nuclei, so they are more stable. And this is nuclear fusion is just opposite to that of the nuclear fission. In nuclear fission, when the two or more than two light nuclei are combined to form a big nucleus or a large nucleus, then this phenomena is termed as the nuclear fusion. So the product nuclei will have more binding energy per nucleon in comparison to the parent nuclei, as it can be seen from the binding energy curve. When two or more than two light nuclei are combined to form a big nucleus, it is called nuclear fusion. Nuclear fusion. The daughter nuclei have more binding energy per nucleon than the daughter nuclei have more binding energy per nucleon than parent nuclei. As it can be seen from binding energy per nucleon curve. The nucleus has positive charge, so they experience Coulomb repulsion force. Their fusion cannot take place at low temperature. It requires a very high temperature and pressure to overcome the Coulomb repulsion. Coulomb repulsion between the nuclei. Because of it, because of very high temperature and pressure, the nuclear fusion is called thermonuclear reaction. Reaction is called thermonuclear reaction. Thermonuclear reaction. So, since there is a force of repulsion between the nuclei due to being the positive charge, so it is necessary to overcome the Coulomb repulsion, otherwise they will not fuse. So, for having a nuclear fission, we have to make a very high temperature and very high pressure so that the nucleus may come close to each other, and then they will fuse and will make a heavy nucleus. So because of very high temperature and very high pressure, these kind of reactions are also called the thermonuclear reactions. So now it can be seen that in the product, whatever the nucleus is obtained, that have more binding energy. So the product nucleus is more stable than the parent nucleus. Now we can have an example. Suppose we have this hydrogen These are the two hydrogen. When they fuse, they make a deuterium plus positron plus neutrino and have the energy of 4 mega electron volt. So energy is liberated in all these because so they are exothermic nuclear reactions. And also they can have this, suppose we have this H12 and H13. This is deuterium and this is the tritium. When they are fusion, then this makes a helium nucleus plus a neutron plus the emission of some energy that is now your 17.6 mega electron volt. And similarly, we fuse this H12 plus He23. This is the isotope of the helium. Then it will make this He24 plus a proton plus the emission of the energy that is 18.3 mega electron volt. So there are so many reactions in which the energy is liberated. Due to mass defect, the energy in nuclear fusion is liberated. So it is exothermic. These reactions are exothermic reactions. These reactions are exothermic reactions. Now, when this concept of nuclear fission was given, then it was thought that this cannot be take place at the room temperature because very high pressure and very high temperature cannot be created. For nuclear fission, we need say lakhs of temperature and lakhs of pressure. That is not possible on the ground. So this nuclear fission cannot be carried out at the room temperature. The nuclear fusion cannot be carried out on the room temperature. Generally, these kind of reactions take place at the sun or the stars which are having their own energy, and in these stars the temperature is very much high and the pressure is very much high, so they are emitting their energy in the form of light and then that of the gamma rays, etc. So this is why that you can see that we are getting the heat from the sun, and sun gives us the light and so many energies. And at the sun there is the nuclear fusion. There is presence of hydrogen that is converted into the helium, and we can see that approximately 90% of the mass of solar system is concentrated in the sun. So nuclear fusion takes place only in stars, and it is called the stellar energy. Nuclear fusion takes place in stars. Like sun. So this is about the nuclear reaction or the thermonuclear reaction. So you like, share, subscribe this video. Thank you.